Okay, so you can see a little time has passed, the sun is setting. Well, let's talk about what your homework is going to be for this week. Um, so this is another 2-week project. You're going to be thinking about this idea of randomness, and really, like the super short version is to make something really cool that uses randomness in as many ways as you can. So cramming it into your sketch in all kinds of places, and really exploring what happens when you release a lot of the control that you would normally have writing code or making art, and instead of turning it over to randomness. And there's a lot here, so we're going to go through kind of the highlights, and then you want to check out the details of the assignment. But it starts with a quote by A. Michael Noll, who in the 70s at Bell Labs in New Jersey was kind of an early pioneer of art and the computer. And he says the computer is a unique device for the arts since it can function solely as an obedient tool with vast capabilities for controlling complicated and involved processes. But then again, full exploitation of its unique talents for controlled randomness and detailed algorithms could result in an entirely new machine, a creative artistic medium. I love this. Not only is this in 1970, like this is computers were a completely different thing back then, hard to get access to. Most artists wouldn't ever have been able to work on a computer. Um, and yet here is a Michael Noll talking about using computers as a new kind of creative artistic medium. That's really what we're doing here in this class. But I think what's extra cool is he's talking about this idea of randomness, and this being a really important idea from the early days of software art, the kinds of things that we're doing. Um, so your goal, like I said, is to think about randomness as a tool that both breaks the determinism of the computer, but also as a tool that you can apply to visual parameters in the thing that you're making and see new and exciting results. So think about all the places that you could plug randomness into: size, position, rotation, color, the number of iterations. I'm sure you could think of many, many more. And one of the other things that I find super exciting about working with randomness in code is that every time you run your sketch, you're going to get a different result. And that can be frustrating because it might be fleeting and you can't get back to the thing you wanted. But I also think this is really cool. So, in a way, your role is no longer as the artist, but almost more as like director and curator, where you are crafting this system that generates these outputs and then curating the results of the ones that you like the best. And this is a very different way of working, but I think can be really productive and really cool. Um, so this is divided into 2 weeks. The first week, you're going to make exploratory sketches in code thinking about randomness. So at least 3, maybe more. And the idea is to explore really a range of possibility here. So they may be somewhat similar, but I want you really to go crazy and just try a bunch of stuff and see what you come up with. And again, the goal is to pack as many of these randomly controlled values as possible, while also still, thinking about the ideas of art and design, color, composition, symmetry, that kind of stuff. Then we're going to talk about the readings in a second. And then in the second week, you're going to continue this and pick one that you like and create a final iteration. So then going back to it and reworking it with the feedback from the group, and thinking about what you're excited about and making it great. Thinking about adding more randomized parameters. What happens when you start layering things can be really cool. So maybe you do a bunch of runs of these overlapping random shapes, maybe doing rotation or something like that, color change, that sort of thing. And also, of course, thinking about the historical examples that we're going to look at now that might inspire your project. You can check out kind of the details of the deliverables, but a couple of stretch goals. And again, these are like optional things if you're cruising along and you want to take on a challenge. Could you add random parameters to your exported file name? So, that save command at the very end, you could easily add, keep track of all the variables that are randomly generated and then create a file name so that later you could go back and recreate the same thing. And could you in some way use a hardware-based random number generator in conjunction with your code? So like the random seed example we looked at, could you use dice or a coin toss or some algorithm you create physically a natural system like weather or birds at your window or whatever, and have this like come into your program and then maybe also conceptually tied together. So if you're generating these like random bird shapes, maybe you use the the birds outside as a way of like seeding your random number generator, and that becomes really cool. I have a lot of links here for some things, but really the bulk of what we're going to look at now is in the images folder. So let's take a look at that. I think you'll really like these. These are really cool. So let's start with A. Michael Noll. This is one of his pieces from the early days. This is actually even earlier. This is in the 1960s. And these are frames from a video. So this is an animation. Unfortunately, a lot of this stuff gets lost to history. But these are these kind of randomly generated. And this probably looks kind of like Brownian motion. So like we start to see some things there that look familiar. Charles Sisuri, Random War. This is a piece from 1967. Again, yeah, some of these things, there's only low-res versions available, unfortunately. This is a very different look. So A. Michael Noll and a lot of the examples we'll see today are very geometric. This is using kind of like a line drawing of these toy soldiers. And this is from 1967. So Vietnam War, this idea of random war becomes much more loaded than just like these sort of figures. It's a critique about the randomness of this violence that's happening and using the computer as an integral tool to talk about that idea. Another important early computer artist who's still alive and making really cool stuff is Frieder Nack. This is from 1965, called Polygon Course number 7. We don't often have access to the source code for these pieces either. All we have is the output, so we can only guess kind of how this was made. But I really like this, and this is a similar one from 1965. Yeah, I mean, we could totally start unpacking and try to figure out how these things are made, which is pretty cool too. Manfred Moore, we talked about. Here he is with his rock and stash and his plotter. This is actually at the National Meteorological Center in Paris. So it's one of few places, in the 1970s, this is 1970, artists didn't really have easy access to computers and that kind of stuff. So having a plotter, no artist would have had a plotter at that time. You have to go borrow time on the computer, borrow time on the plotter. And these are some results. So this is a piece called P10-2, Random Walk from 1969. This is another one. Maybe we can make it a little bigger. Again, yeah, it's kind of hard to see from these images online, but this I really love. So it's almost like a deforming, crumpling square. Here's a close-up of the plotter rendering this piece, which is called White Noise. This is from 1971. So it's kind of like a line that then is being distorted variously as we go along. And one of my favorite artists, Vera Molnar, she is still alive as well, making really cool stuff with computers even now. But this is from 1975-76, called Hypertransformations. And I think this piece and a lot of her early work is a great example of a simple idea, but executed really elegantly. So it's a square on the outside that then is getting smaller and being deformed slightly and smaller and deformed more and more, and just like repeating that, and then this final square in the middle that's unchanged. This is from a similar time period, 68-69, called Interruptions. Again, we can start to see how this is made in a similar way to how what we've covered already, right? So you've got randomly rotated lines on a grid, and then randomly choosing not to draw a line. So this even harkens back to the very first week, things like Sol LeWitt and these instruction drawings. And we can start to kind of see the algorithm, the recipe by which these are made. This is called square structures. I believe these are also deformed squares in a kind of a grid. Different colors really change this too, like the layering, the energy and vibrancy of this is really cool. And this is in an untitled piece from 1968. One of the reasons I love this is it's generated in the computer, but then printed or plotted probably, and then it involves hand painting with like watercolor or something. So mixing those two media as well is really cool. Some other examples in no particular order. This is Anthony Gormley, who's a contemporary British sculptor. This is from 1999. If you kind of squint your eyes, you can see a human figure that's then, and this is made of welded steel, I believe, and then that figure is sort of like disintegrating into this cloud shape. Here's another version of that. This is huge, so this pier maybe gives you some sense of scale here. Here's another version of that. You can see the human figure in there. Oh, if any of you are into games, Dwarf Fortress is awesome. I find it an unplayable game, but I love the backstory. So Dwarf Fortress is this game, it's called a rogue-like, and this is kind of a genre of games, sort of a strategy game. I've actually never played the game. I just really love how it works. So when you create a new game, it generates this whole history for this world. It generates landforms, it generates terrain and water, it generates civilizations and cultures and languages and histories for them and wars and people, all of which just gets you to the present moment when you start playing the game. And depending on the settings, this can take hours for it to kind of generate. This is a contemporary game. This is like a new game. But I love they are spending so much time building this like random world builder only for you then to be able to play in that world. It's really cool. Ellsworth Kelly is a late 20th century or middle 20th century, late 20th century abstract painter, American, and this is from 1951. This is called Spectrum, Colors Arranged by Chance. Again, we don't know the exact process, but you can imagine, pieces of colored paper cut out that are then sort of arranged using some random process. And it's also highly likely that he generated many of these and picked the ones that he liked the best. Jake and Dinos Chapman are an artist duo, also contemporary. This is from a series of prints. These are etchings from their series Exquisite Corpse, which is a game you may have played where you fold a piece of paper and one person draws like the head, and then you fold it over and pass it to someone else, and they draw the body, and then they draw the legs or whatever. And so these are their kind of like really nasty, awesome take on these, which I love. This is from 1933. This is a piece by Jean Arp. It's called According to the Laws of Chance. And it's my understanding these are torn pieces of black paper that then Jean Arp drops from up high. They land on this big piece of paper, and then they get glued down in this form. This is a contemporary project by John Menick and Agnesa Courant, and it's called Production Line, Turker lines combined into drawings. So essentially it's two artists, they went on to Amazon's Mechanical Turk service, where you can hire people around the world to do small kind of menial tasks. Often it's like labeling photographs and things like that. And they ask them to draw a straight line, and that's it. And then they collect all these lines together, and it forms these drawings. And I love that, some of them are horizontal or vertical, some are diagonal, some are not straight, some are very straight. It's pretty cool. Oh, here's one more. Kenneth Martin, British painter. This is from 1972, called Chance and Order. Again, I don't know a lot about the process behind these, but these are very, very big. And this is a preparatory drawing for some of these. I actually like this much better than the final painting, but you can see like the process, the working that's happening here. And I think that's something that often gets lost in the computer. So if you want to think again, like we were talking about random seed, ways of bringing in stuff from the real world into the computer, I think is always really interesting and exciting. Oh, here's a couple more. Black and white one. Again, we start to think about like, oh, how could I make this in processing? We talked about Manfred Moore. This is another favorite of mine. This is Raymond Quinoa, who is a poet associated with this movement called Oulipo, which were very interested in rules and ways of making poetry and writing that really kind of broke down personal preference and changed, like allowed new ways of working. And this is called 100,000 Billion Poems from 1961. It's a book, as you can see. It's a bunch of poems and each line is cut so that they kind of just are floating, and you can rearrange. And I haven't done the math. I don't know if this actually adds up to be 100,000 billion different poems, but the idea is that it's no longer fixed, but able to be rearranged, which I really think is super cool. And that's just a tiny, a tiny bit of some artists who have been working with this over time. A couple other things. I really love the devices of computing, and especially when they embody some kind of idea. So here's some cryptographic technologies. Again, this is used for like secrecy and privacy. A lot of these are from the Crypto Museum. This is a cryptographic key in the form of a little circuit board that you would plug in. So it's like a password, but in the form of a circuit board. These are dice developed by Galton. Let's see, is it going to let me make it bigger? Yes, okay. So Galton was an early pioneer in probability and thinking about how like populations evolve and things like that. So these are dice that he had designed and made. These are the original dice. This is like late 1800s for creating random numbers. This is one of my favorite websites. If you can't already tell, I'm a total nerd for random numbers in particular. This is from a website that still exists called random.org. This is their original setup for generating random numbers. And so what they have here is a computer and a server. I'm not sure which is which. And then an FM radio that's tuned in between the stations. So when you're in between FM stations, what you're really hearing is noise in the atmosphere. And then the computer is sampling that sound to generate random numbers. Of course, there's other stuff on the shelf here. And I think, I thought I had, this is version 2. So slightly more sophisticated. I love the note, do not touch these radios. And there's actually 2 radios which help somehow mathematically like remove any chance of it being less random. And again, the computer and all that stuff. What else did I want to show you? Oh, this is a voice scrambler. Again, this is from the Crypto Museum. This is military technology. I don't really know what it does, in its guts, but I love like the look of it. This thing generates random noise that then scrambles your voice. And then Sig Sally. So Sig Sally is another personal obsession of mine. This is a World War II era project between the US and England. And what you're seeing here with these 2 gentlemen is 2 turntables. These are like the size of a refrigerator. And each one is super, super carefully made. And there's a record on top. And the record is white noise. It's just, just noise. But they're very carefully made. So each side, in the US and in England, they had matching records. And when the president wanted to call England, he would pick up the phone, the special phone. They would play the record, and those 2 signals would get added together. So it would sound just like crazy noise. And on the other side, they would play their record in sync, and it would remove that noise, and the person on the other end could hear their voice. This is an example of that record. I've been hunting forever to try to find one of these. I believe they're all gone, which is really too bad. But I'm obsessed with Sig Sally. And then lastly, we could easily, I could easily, maybe you couldn't, I could easily spend ages talking about random numbers. This device doesn't seem, other than being, I think, beautiful, that important. But this was used to generate a really important book called A Million Random Digits by the Rand Corporation. And A Million Random Digits is literally that. It's a book of random numbers. And that seems so silly. This is in the 1950s. It seems so silly now because we can see in P5JS, it's super easy to make a random number. But back then, keep in mind, people didn't have access to computers in the same way. And generating really good random numbers was really tricky, but also super important. So for things like computer simulation, especially for developing nuclear weapons, but also for any kind of modeling and simulation, this was really, really important. And this book produced by the Rand Corporation ended up being hugely important for many, many years. You can actually download a copy of it for free from their site now. And this is the device that they use. So this is a white noise generator, and you can't see it, but I have one of them. I bought it on eBay because I'm too obsessed, and I have one, and I love it. It's also just a beautiful object. There's some other stuff here that you might want to check out. So if you're curious and you want to read more or check out some more stuff, you can look at that. And then I wanted to share with you one other thing that I'd like you to do. In a week, we're going to be talking about this idea of open source and free software. This is a really interesting and important topic related to what we're doing. So obviously it's not creative computing, but the way that we make and release software into the world is a really important personal and political act. And for many, many years, there's been a movement kind of against people like Microsoft, Adobe, those kind of places that make paid software. And they say software should be free. We want to release software into the world. And so I have two short PDFs that I'd like you to read that talk about why you might make free and open source software. Like, why would you give away something that you made? And I think a good connection too is the P5JS project we saw earlier, that in the random seed video, that you can see the source code for P5JS, and the same for the older versions of processing. So there's two documents I'd like you to read. There's also some optional stuff in here. There's quite a bit. Ted Nelson's 1987 Computer Lib and Dream Machine is a really important document, and got lots of crazy drawings. There's the Debian Constitution, which is part of Linux. Debian Social Contract. There's a bunch of stuff in here. So if you're really, really interested, this would be great places to start. So that's it. Randomness. TLDR, go make something super cool with randomness. Cram as much randomness in as you can. And I'm really psyched to see what you make.